Alright guys, today what we're going to do is look at trapezoid 6.5. This is your work for Monday, which would be, I believe, the 23rd. Should be the 23rd Monday. We're going to talk about trapezoids. First of all, what a trapezoid is it's going to be a quadrilateral with exactly one set, a pair of parallel sides. So we're looking at quadrilateral with one pair of parallel sides right here. Okay, a couple of characteristics of a trapezoid, just a regular trapezoid, is that you're going to see that two consecutive angles here, okay? Two consecutive angles are not congruent, but they're going to be supplementary. Okay, so they're going to add up to 180 degrees, those two angles. And really what they are, if you look at the two parallel lines, these are really consecutive interior angles. We know from before, they're going to add up to 180 degrees. And I probably should have labeled a couple things that you're going to have here. On top, you're going to have your base, your first base, and the bottom, that's your second base. These are your two bases. And on the side, you're going to have your legs. Okay? You got a leg here and a leg right here. Okay? So these two bases are going to be parallel. And always, this base angle here in the bottom to the top, they're almost like consecutive interior angles. They're going to add up to 180. So say if I gave you this angle at 60 degrees, this would have to be 120. Okay? So that's basically what we're talking about when we're talking about a trapezoid. Okay? Now, the type of trapezoid you're going to see a lot of is an isosceles trapezoid. Okay, I'm going to move this up here, erase this. With an isosceles trapezoid, okay, you're going to have your bases that obviously are parallel, but your legs are going to be congruent, okay? Your base angles are going to be congruent. You've got base angles at the bottom, and you have them up here. In an isosceles trapezoid. Okay, so this is unique to an isosceles trapezoid. You're still going to have your consecutive interior angles. I like calling that because that's something we can relate to. It's like a transversal hitting two parallel lines. These are going to be supplementary, meaning they have to add up to 180 degrees. Again, the two bottom base angles are going to be congruent, two top angles, base angles are going to be congruent when we're talking about an isosceles triangle, or I'm sorry, isosceles trapezoid. Okay, let's see what we have here. We're going to go down to a couple of examples. And we want to find the measure of the angle indicated in the trapezoid here. Okay, so if this is 108, again, these are like consecutive interior angles. A couple of things we want to notate. If we have a trapezoid, we know these two bases are going to be parallel. Okay, and we said with a trapezoid, if you're looking at angle E and angle D, and that's what you're asking for, angle D, okay, they are going to be consecutive, just like consecutive interior angles. So they're going to be supplementary. So that means that angle D has to add up with 108 to give you 180. So D and E you have to add together to give you 180. Or we could just say 180 minus 108 is going to be what angle D is equal to. And that would be 72 degrees. Okay, so this would be 72 degrees. Because again, these two angles have to add up to 180. Now you don't necessarily know that this is going to be 72 degrees. Even though it looks like it, they don't say that it's an isosceles trapezoid. Okay. Now here, you know you have an isosceles trapezoid because they say it's a trapezoid. We know these two lines are parallel. And we also know that LK and MN, the two legs, are going to be congruent. So yes, this is an isosceles trapezoid here. It's an isosceles trapezoid. All right? So a couple things we know. We know that if this is 115, 115 angle L and angle K are going to have to add up together to equal 180. All right? So we know that angle K would have to be 65 degrees, right? Because 180 minus 115 equals angle K, which is 65 degrees. And we also know, since it's an isosceles trapezoid, that the base angles are going to be congruent. Okay? Base angles at the bottom, base angles at the top are going to be congruent. So that's why this angle here, angle N, would also be 65 degrees. Okay? So, very quickly here as we're going through the trapezoid, we're seeing different characteristics that are going to help you to solve some of the problems that you're going to see on the worksheet. And again, just like I've been doing, I'll do maybe the first example in each section, then you can follow along from there, and always make sure that you can refer back to your notes. Okay? So that's our first two examples there. And then here, I'm going to give you a little bit of time. Let me erase this. Take that off of there. Give you about a minute here if you want to do some of these problems. Do 1, 2, and 3 there. Okay, let's look and see what we have here. For our first trapezoid, again, you see angle M is 135 degrees. This is just a regular trapezoid. It's not an isosceles trapezoid. Obviously, you know that the bases are going to be parallel. You also know that these two angles are like consecutive interior angles. All right, they have to add together to give you 180, or you take 135 away from 180, and that's going to give you what angle N is equal to. And angle N is going to equal 45 degrees. Okay? Angle N is going to be 45 degrees. Next, we look at an isosceles trapezoid, and this is an easy one. We know with an isosceles trapezoid, your base angles here are going to be congruent. So D is 60 degrees, you know angle A is going to equal 60 degrees. That's a quick one, but that just comes from you having knowledge of knowing that the base angles of an isosceles trapezoid are going to be congruent. Okay? We see another isosceles trapezoid. We see this at 75 degrees. Again, base angles are congruent. Once we get one of these angles, we know both of them have to add up to 180. So we just take 75 away from the 180, and we're going to get angle Q equal to 105 degrees. Okay? So just a quick exercise in applying some of the characteristics of a trapezoid. Okay, and an isosceles trapezoid in 2 and 3. Okay, the next thing we're going to look at is a mid-segment. Now we looked at mid-segments when we talked about triangles. Now we're going to look at a mid-segment when we're talking about a trapezoid. Okay, the mid-segment, I'm going to try to make this a little bit bigger here. The biggest thing we have to know about a mid-segment, well, a couple things. First of all, just like a triangle, when we have a mid-segment coming across, it's going to break each side in half. So we know whatever, if we're given a measurement for the top part right here, we know the bottom part is going to be the same. Same thing over here. If we're given a measurement for the top part, bottom part's the same. If we're given a measurement for the bottom part, top part's going to be the same. Or if we're given a measurement for the entire side here, we just cut it in half, and that's going to tell us what each part is. Okay? So, in other words, if say this whole area was, whole line here, side, or leg, I guess is a better way of putting it, it's going to be 8, this would be 4, and this would be 4. Okay? If this was, say, 6, this is 3, this is 3. So kind of the same basic idea of what we're talking about when we're talking about mid-segments in reference to triangles. Okay, now we're just going to look at a couple of examples here. We're going to go down and we're going to look for the length indicated in the trapezoid of the mid-segment or the base. Okay, so a couple of things we want to do here, and I think I'm going to loop this back up and add one more thing to the mid-segment. I was going to do it within the problem, but I think I'll do it up here. Okay, with this mid-segment here, okay, what you're going to do is your mid-segment you're going to try and find a value, you're going to kind of use this formula. Okay, mid-segment is going to equal 1/2 of base 1 plus base 2. All right, I think you'll see this a little more clear in an example. I actually was just going to introduce an example, but it's probably good to see up here. Another way of writing this, and we know this from when we talked about triangles, instead of saying the mid-segment is 1/2 base 1 plus base 2, you could also write this as 2 times your mid-segment equals base 1 plus base 2. Okay, so if we had, say, base 1 here, base 2. This is your mid-segment, okay? 2 times your mid-segment is going to equal base 1 plus base 2. This is the formula, but I like going right to the second step. Just like we did with triangles, makes it easier. Just, you don't have to worry about a fraction. You can save a step. So just do 2 times your mid-segment is going to equal base 1 plus base 2. Okay, so that's your general formula right there. And I think, it's better off just showing it initially right up here. Okay, so let's raise up our examples right here. And we're going to look at finding UT, or mid-segment. We're going to call this X. You have the question mark, but we're going to call it X. So this is your mid-segment. So 2 times your mid-segment, I'll write this formula, equals, I'll just call this B1 plus B2. I'll call the bottom one B1, top one B2. It doesn't matter which one's which because you're just adding them both together. So this is going to be base 1, this is base 2. Okay, and this is your mid-segment. Not going to be a factor here, but remember, mid-segment, just to remind you, cuts both these sides in half. Again, not going to be a big factor on this one. So 2 times your mid-segment right here, so it's 2 times X is going to equal base 1, 6.1, plus base 2, 10.1. Okay? My 2X is going to equal 16.2. X is going to equal 8.1. So my mid-segment is going to be 8.1. Okay? that's basically what you're looking at when you're looking at an example. And then, you know, just write everything in from the formula. A lot like, almost the same kind of idea as when we had a triangle. Okay. And again, I just like writing my formula, putting everything down in an organized way. 2 times my mid-segment, 2 times mid-segment equals base 1 plus base 2. Okay, I have my base 1 here, my base 2 here, and this is my mid-segment. Right here. Okay? So 2 times 13 is going to equal, here we'll call this x. If it's an unknown, we'll call it x. X plus 6. Right? 2 times 13, again, we used 13 was our mid-segment, and 2 is in the formula. So that's going to be 26 equals x plus 6. We subtract 6, 20 equals x. Okay. And it makes sense. Okay, you can always go back and check. 20 plus 6 gives you 26. Half of that would be 13, or 2 times 13 gives you 26. Okay, so take a look at that. You can, obviously, with what we're doing here, you can stop the screen and copy everything down. I'll give you a few seconds to do that also. And then I'm going to have you guys attempt example 3. No, we'll do example 3 together, actually. We'll do example 3 together. So let's move down to that. And I think the big thing in example 3, and again, this is where having experience in doing these with triangles is going to help you here. Okay? If we have, we're trying to find the value of x, okay, on the first one, and we're going to look at 2 times the mid-segment equals base 1 I just like rewriting it every time. Again, when I do this the first time around, I always tell you, I'll write more than you need to write. If you want to get, at this point, get right into writing 2 times 49 is going to equal 5x plus 4 plus 74. You can do that, okay? And then we just do the math here. We solve the equation. 2 times 49 is going to give you 98 equals 5x plus 78. Okay. Subtract your 78. Subtract your 78. We get 20 equals 5x. Divide by 5. Divide by 5. 4 is going to equal x. Okay? And it makes sense. Okay, if we plug this back in, 5 times 4 is 20. We get 24 here, plus your 74 is going to give you 98. Half of 98 is 49, or 2 times 49 gives you 98. Okay? So that's your example right there. Okay, now, on this next one, and you'll remember this from when we had our triangles and had the mid-segment. All right? 2 times your mid-segment equals base 1 plus base 2. Mid-segment. Now, one thing we want to remember to do here when we do 2 times the mid-segment is we've got to remember we're multiplying 2 by this, it's by the whole thing. So we're going to put parentheses around it, and we've got to remember to distribute. Okay, you've got to remember to distribute here. Again, remember that we had the same type of thing with the triangles in the mid-segment. And that's going to equal base 1, 46, plus 16. Okay? So we do our algebra here, we solve the equation, distribute the 2 times the 6x, we get 12x. 2 times the negative 17 gives us minus 34, and that's going to equal 46 plus 16, 62. Okay. Then we're going to add our 34. Add our 34, cancels out here. We're going to get 12x equals 96, divide by 12, and x equals 8. Okay? You're going to get x equal to 8. Okay. And again, it makes sense here. You're going to have your 46 and your 16, 62, and then your 6x, which is 6 times 8, 48, minus 17, gives us 31. So this 31, when we check it, will be half of 46 plus 16, 62. All right, so when you have time, when you get a test, or even on the worksheet you're doing, double check your work, fill it back in. Okay, so that's it. Basically, trapezoids are what we covered on this. And again, if you have any questions, definitely reach me via email, and we'll get things squared away.